Hello guys, so I have prepared a new video, okay, about this is continuation of the flexural stress that I discussed during our face-to-face meeting. Diba nagtulog ko sa inyo bending stress, that is in terms of FB is equal to what? MC over I, or just M over what? M over the X. Tama? Now, so ang akong gi-discuss sa inyo is more on prismatic beam or homogeneous beam. When we say homogeneous beam, is that we have one material lang. So pag concrete lang ato ang beam, so entire beam kay concrete. Okay? Or pag steel lang ato ang beam, so therefore the entire material is steel. Okay? So that is a homogeneous beam. Same material tanan, but what if our beam is composite? When we say composite, that is a combination of more than one material. Okay? Now take note, ang ato ang material naglahi-lahi ihang modulus of elasticity, tama? Naglahi-lahi ang E. So therefore, in this case, now look at the stress distribution, this one. Ang sinitabo, we have different stress. Dili siya uniform stress all throughout. Take note of this. The reason is that lahi ang ato ang modulus of elasticity ana, lahi ang iyang strain distribution, okay, kay lahi ang iyang E. So therefore, in dealing with composite beam or material with two different beam with having or a combination of two materials, no, ang atong himuna na is we convert ato ang himunog uniform ang ilahang material. O sa una pag uniform, so i-convert nato ang isa ka material into i-convert nato ang isa ka material, i-transform nato siya to the material na ihang kauban in the beam, for example. Now in this case, no, we have the wood. We have the wood, di ba? And let's say that's steel. So, ang atong himuon, it's either you convert wood into steel, i-convert siya into steel, para ma-uniform ato ang beam, or ang steel, i-convert mo siya into wood. Okay? You make the beam uniform. Okay? So, imo silang i-convert into specific. Now, we have the relationship between the modulus of elasticity of two material. Now, we have elasticity 2, this one, that is the material na gusto nimo i-transform, i-divide nimo siya into E or the modulus of elasticity of the reference material. This is reference material, that is katong i-stay lang nimo nga material. So the ratio is what we call N, or N, that is the modular ratio. Okay. The modular ratio. Now, pag makita nimo sa N, himuon mo siya og factor. Okay, like for example, if this is your beam, take note kay lahat ng material, we have A1 and A2, two combination of two materials. Now, to make your A2 para ma-convert siya into A1, then you just multiply A2 into N. Okay? So, natay N, multiply lang nimo, or that is just N times B. Okay? So, ang base nimo is i-multiply nimo siya into modular ratio, and these two material, these two section now are uniform na. So, they are uniform material na sila. Okay? So mura siya i-convert nimo siya into similar material. Okay? Para maka-create ta o para maka-apply ta sa tong frictional stress. So, ano lang, get the modular ratio and so on. Okay, so let's try to solve an example. Okay, we have here an example. A 3-meter long cantilever beam carries a uniformly distributed load. We have 2,200 Newton per meter. The beam is constructed from a 90 mm wide by 240 mm deep wood timber. So, this one. Okay, mo daw ni siya tong timber. and that is reinforced on its upper surface by a 90 mm by 10 mm thick aluminum plate. So, kani. Okay. Anong naman siya reinforcement tira? What's the reason? Anong kailangan siya mag-build up beam tira? It's because para mo taas ang ato ang stress at this point. Ay ang bending capacity, no, para masisud siya i-bend. The elastic modulus of wood is E 11.5 gigapascal and the elastic modulus of the aluminum plate is 69 gigapascal. Determine the maximum bending stress produced in timber 1 and aluminum plate 2. So we determine the beam, or we determine the flexural stress for each material. Now, since they have different materials, so i-convert na to ang isa sa ilaha, okay, into different, or into similar material rather. However, we get first the maximum moment. Syempre, di ba? From our formula, FBMCI, we need to get the M. Now, take note, this is a cantilever beam. Cantilever beam na siya. So, we have, pila yung load? Load is 2,200 Newton meter. And the length is what? 3 meters. Okay, what is now the moment? So, moment, it is just, moment, diba dali? Kani siyang moment, ang atong maximum. So, di ba, kuha lang siya? 2,000, dito na lang na ako, 200 times 3 times 1.5. So, pila si M? M is equal to 2,200 times 1.5, that is 9,900. 9,900 Newton meter. Okay? So in that case, na natin moment, so kailangan nato siya i-convert. Ato i-convert dari kay steel. Ato siya i-convert into wood. Or pwede po si wood, i-convert into steel. So let's try to compute both ways. Okay, so we have, convert nato, no? So, ito himuon, mapangitaon sa nato ilang modular ratio. We have N is equal to the E na gusto nimo i-transform over E gusto nimo na i-retain, or that is your reference. So, ang transform nato si steel. What is the E of steel? The E of steel kay we have 69. Okay, 69 GPa. Over E reference, ang E reference nato is what? We have 11.5. 11.5. So you have now N is equal to what? 69 over 11.5. Then you have 6. 6 ang imong factor, or your modular ratio. Okay, in this case, ma-convert na nato. So again, at himuon ani si 90, this one here, 90, ato siya i-times og 6. So, pila na siya? May tabuan na is 90 times 6. Lang. 90 times 6, that is now what? Muna yung equivalent with pag wood siya. Okay? That is 540. This now, it's equivalent with, no, pag wood. No, same. Then the thickness still the same. Okay? That is 10 mm. 10 mm. Then, ano siya dira? Sorry. Then you have the base, the height of the wood. Wala, dili ma-change, diba? Okay, since wood naman siya. So this is what? This 90 Correct? And the height is what? 240. So, wood na siya, tanan ang atong materials. Tama? Now, in this case, kailangan na nato i-compute ang atoang I. Or first, get the neutral axis. So, we have the neutral axis. So, again, mag-reference sa dere. X there is 0. That is what? O, also itong area total is equal to 540 times 10 plus 240 times 90. That is equal to what? $27,000. We have 27,000. The unit is mm squared. Okay, so let's try to solve using Varinian's theorem. We have area total, barred y is equal to the summation of all the area, then x. Tama? We have 27,000. Atong reference kay nadari dapita. Okay, this is our y0 times barred y is equal to, we have 540 times 10 times the distance from the centroid up to this point, that is what? 240 plus 10 minus 5, tama ba? 240 plus 10 minus 5, we have 245. Okay, it's 245 sunod plus 240 times 90 times 240 divided by 2, that's 120. Okay, so you have now your barred y is equal to what? 540 times 10 times 245 plus 240 times 90 times 120 is equal to 27,000. Then you have 145 from the bottom. Okay, so 145 na adri dapita. Let's say na adri dapita. It's the neutral axis. Again, pag neutral axis ta, ang atoang flexural stress at that point is 0, di ba? Always 0. Next, we have next we compute for the I. Okay, so transform moment of inertia. So we have IG. First is 540 times 10 cubed over 12, tama? Plus 540 times 10, tama? Times from the neutral axis, kani this point, kaninga point, pila na siya? If that is 145, pila ni siya dapit dare? That is 145 minus 250, that is 105. I guess it's 105. So therefore, this is what? 105 minus 5 squared, tama? Plus, so wood, we have 240 times cube times 90 over 12, correct? 240 cube times 90 divided by 12 plus 240 times 90 times the height is kanina rin, no? That is 120. So this distance pila. 145 minus 120 is equal to 25. It's correct? It's 25. So times 25 squared. So pila ato ang I? I is equal to what? Okay, nag-compute pa ko. Still computing. Okay, so the result is 171. Okay. 0.225 times 10 raised to the 6th. The unit is mm to the fourth. After this, you have know your I, then you can compute for the stress or the flexural stress for each material. Okay, asa dapit ang ato ang stress diri kang wood. Di ba ang kay wood nga stress, the maximum stress sa wood is within this point. Within this point. So therefore, that is the stress at that point. Stress dere. Okay, so kanang stress dira, which is unsa man siya, compressive or tensile. It is tensile stress kaya nga to ang bending pang ani no. Pang ani itong bending. Okay, so we have compute. We have now for the wood. However, since gipangutana is the maximum, pangitaaw na to tong maximum C. Asa dapit dira atong maximum C. Our maximum C for the wood is at the where? At the bottom, tama? Kay dako-dako man. Di siya, this is 145 good ni, no? 145. So dira mo ni ato ang para makuha tag maximum stress. That is what we have. For the wood, we have FB is equal to what? MC over I. M is what? M is the moment, that is 990, 9,900, sorry. C is equal to what? 145. Tama? Now, take note, si 9,900 is naka-Newton meter. So, therefore, kailangan ta mag-multiply pila lang. 1,000 lang. Correct? 1,000 lang. Dili siya 10 raised to the 6. Again, kay naka-Newton lang man. Unless kung naka-kilonewton na siya, then we multiply it into times 10 raised to the 6. So, tamaan ng 1,000, kay meter lang mo na ito i-convert into mm. Divided by 171.225 times 10 raised to the 6. So we have FB is equal to what? That is over 171.225 times 10 raised to the 6. The result is 8.38, correct? That is 8.384 MPa. Now, take note, also man siya, is it compressive stress or tensile stress? That is now this compressive stress. Kaya at the bottom man ta, at this point, no? At this point. So, we get the compressive stress aning nga point there at this section. So, therefore, that is compression. Kaya again, ito ang bending is pa, yung ani. Now, which is at the bottom, compression, at the top kay tensile. Now, the next question is the compressive or the maximum bending stress for the beam, for the steel rather. So dapat mag-occur ang maximum compressive, the maximum stress of the beam at this point, tama? At this point, kaya mo man ang pinakadakog C, so we have 100. Now, take note is for the steel. That is what? FB is equal to MC over I, correct? MC over I. Now, take note, di ba ang ato ang I dere, no? Ang ato ang stress dere is naka-wood. So, we multiplied it by the modular ratio para makakuha taog steel nga flexural stress. Kaya again, wood pa ni siya atong nakuha. To make it compressive stress for the steel, we multiply the modular ratio. That is what? 6 times the M. M is 9, pero ito siya, 9,900. Now, what is now the C? From the tip or from the top surface, this one, that is 105. That is 105 over I. Our I here is 171.225 times 10 raised to the 6. So therefore, we have now FB6 times 9,900 times 105 over 171.225 times 10 raised to the 6, and computing, that is equivalent to, now take note, again, mag-multiply pa itag 1,000 dere para ma-convert into mm. So 1,000, that is 36.4. That is for 36.43 36.4 426 MPa. Kung saan man siya, is it tensile or compressive stress? That is tensile stress kay at the upward, since it is upward. Or again, at this point here, ang ma-experience niya is tension. Hence, tensile stress siya. Okay, so the answer, this is for the steel and this is for the wood, the maximum. Okay? So, ano lang. So, that is for flexural stress.